Welcome to Math Minders Academy. Today we'll be finding solution to Waec November 2010. We've done part 1 of this series where we cover solution to question number 1 to number 10. If you have not watched that video, go check it out. Today tutorial, we are going to focus on providing solution to questions number 11 through number 20. So let's go. Question number 11. Now it's a continuation of this question from number 10, where we are given that y equals 2s squared plus 3s minus 2. So let's write it down. So here we are told that y equals 2s squared minus 3x minus 2. Let's be sure. Yeah, 2s squared plus 3s minus 2. Okay, so this is plus 3s minus 2. So here we are looking for the minimum value of y. What is the minimum value approximately equal to? Now, we are going to first at that turning point. When we say minimum, we look at the graph is like this. What is the value of x? What is the value of s? It's important we find it. So when we find it, of course, this value of s, we use this formula to get it. So we will substitute it now to get the value of y, which will be the minimum value. So here, a is the coefficient of s squared, which is 2. B is the coefficient of s, which is 3. C is our constant, which is minus 2. So at turning point, the value of s will be minus b all over 2a, which is minus 3 all over 2. A is 2, so we have minus 3 all over 4. Of course, which we can write as minus 0.75. So we've seen that. Now, the minimum value of y, we are going to substitute this value back to this equation. So it's going to give us 2. Our s is minus 0.75 all squared plus 3 times minus 0.75 minus 2. Of course, so here you want to make use of your calculator, and that will give you minus 3.125, which is approximately equal to minus 3. You look at it, you will see that the closest here is actually minus 3.0. All right. Now, if you also look at it, if you want to obtain it from the graph, you will see it around here, around this region here. You'll see the value of y. So that's it from the graph. So we pick the closest of this answer. The closest is minus 3.0, which is this option. It's approximately equal to minus 3.0. We proceed to question number 12. A sector of a circle of radius 3 centimeters subtends an angle of 80 degrees at the center. Find in terms of pi the area of the sector. Now, area of sector is given as theta over 360 times pi r squared. Now, this is going to be 80 over 360 times pi, and our radius is 3. So we have this. If we reduce this, we use 4 here. We have 2 over 9 times pi times 9. Of course, so coming here, this 9 and this 9 will cancel out. We have 2 pi square centimeter. This will be the area in terms of pi, which is option C. So proceed to question number 13. What is the coefficient of SY in the expansion of this? So we are going to use the first item there to expand the second bracket. Then minus 4y, use the minus 4y to expand that second bracket as well. So now when we clear the bracket, this is 2x squared. S times 3y is 3xy. Minus 4 times 2, minus 4y times 2s is minus 8sy. Minus 4 times plus 3y, minus 4y times plus 3y will give us minus 12y squared. So here we have 2x squared. 3sy minus 8sy will give us minus 5xy minus 12y squared. So you can see that the coefficient of sy, if you look at sy here, the coefficient is minus 5, and that is option B. So we mark option B and we proceed to the next question, which is question number 14. Number 14, we are given that logarithm of 9 base s is 2.0000 and log 10 base s is 2.1544. Find log 810. Now, we understand that log AB base C is equals to log A base C plus log B base C. Now, we take note of this law of logarithm is going to be helping us in evaluating this. So we now want to look at log 810 base x. It's going to give us log 90 times 9. 90 times 9 is 810. Now, we break this into log, just like this law says, it's going to be log 90 base x plus log 9 base x. Of course, log 90 base x can be written as, using the same law, can be written as log 9 times 10 base x plus log 9 base x. So this log 90, we have broken it down into 9 times 10. This will give us log 9 base x plus log 10 base x plus log 9 base x. And then putting in what is log 9, we have 2.0000 plus log 10 is 2.1544 plus 2.0000. This altogether will give us 6.1544. That is why we mark this option B as the correct option. We'll proceed now to question number 15. We are asked to evaluate 2 raised to power 6 times 9 raised to power half over 3 raised to power minus 2 times 6 raised to power 2. Now, this is going to give us 64 here times square root of 9. This is the same thing as square root of 9 all over. Of course, if we look at this, this is 1 all over 3 raised to power 2 times 36. So this will give us 64 times square root of 9 is 3 all over, this is 1 over 9 times 36. This becomes 64 times 3 all over 36 over 9 is 4. All right. Of course, if you use 4 to divide 64, if you use 4 to divide 64 here, it gives me 16. So we have 16 times 3, and that gives us 48, which is option D. If you find this video tutorial very interesting, please go on to share this video. If you have not subscribed to our channel, go and click on the subscription button. Please subscribe. Share this so that other students will get it. Go to the comment section, tell us how you feel about it. Let's have your comment, which will serve as our feedback. Let's know how best we can serve you. Please go on and do this. God bless you. Let's proceed to question number 16. Now, we have this. A distance of 5.6 kilometers is represented by a length of 28 millimeters on a map. Use this information to answer question 16 and 17. Now, we want to get the scale of this map. Of course, let's look at 5.6 kilometers. Of course, this represents 28 millimeters, meaning that if I take this to meter, I'm going to multiply by 1,000. Take it again to millimeter, another 1,000. That means I'm multiplying by 1 million. If I look at 5.6 times 10 raised to power, 1 million has 6 zeros. So this is millimeter. We now represent 28 on the map, 28 millimeter on the map. Now, if we look at this, so this is what we get here. Now, I need to get 1 here. I need to get 1 here. So I'm going to do something. I can close up this. I can close up this. This is 5.6 is the same thing as 56. If I reduce this, if I do something, I want to close this decimal. So this can be times 10, then times 10 raised to power 5 millimeter. This will represent 28 millimeter. Now, closing up this will now give me 56 times 10 raised to power 5 millimeter. Good. This will represent 28 millimeter, right? Now, I want to get 1 here. So I'm going to divide both sides by 28. 56 times 10 raised to power 5 over 28 will represent, this side too is 28 mm over 28. Okay, beautiful. Now, let's look at 56. This is 2. So I have 2 times 10 raised to power 5. So this will represent, this is going to represent 1 millimeter. So now that's the scale. So now the scale that we are looking for is 2 times 10 raised to power 5 ratio 1. 2 times 10 raised to power 5 ratio 1. That would be option B. Now, we are done with that scale. We come to number 17. Now say, what length on the ground does 10 centimeter on the map represent? We have 10 centimeter on the map. Remember that 1 millimeter on the map represents 2 times 10 raised to power 5 millimeter, in real life. So I need to get, if I get 10 millimeter here, I'm going to multiply this side also by 10. So it's going to give me 2 times 10 raised to power 6 millimeter. That's for 10. And you know that 10 millimeter is 1 centimeter. So 1 centimeter give me this. Then we are looking at 10 centimeter. So if I multiply further again by 10 centimeter will give me this again times 10 in millimeter. So 10 centimeter is going to give me 2 times 10 raised to power 7 millimeter. Now, if I want to change this part to kilometer, I'm going to divide. Remember when we are bringing the kilometer to millimeter, we use 1 million, we multiply by 1 million. So I'm going to divide by 1 million. I'm going to divide by 1 million here to bring it to kilometers. So because if I divide by 1,000, I will bring it to meters. If I divide by another 1,000, I will move it from meter to kilometer. That means I'm dividing by 1,000 twice. That's 1,000 times 1,000. I'm dividing. The denominator is actually going to be times 1,000, again times 1,000. So that is 1 million. So here, I'm going to have 2 times 10 raised to the power 7 all over 10 raised to the power 6, which is dividing by 1 million. 2 times 10 raised to the power 7. Then this is times 10 raised to the power minus 6, bringing it up. That's 2 times 10 raised to the power 7 minus 6. That gives us 2 times 10 raised to the power 1. And 2 times 10 raised to the power 1 is 20 kilometers. That means 10 centimeter real life, on the map represents an object with a length of 20 kilometers in real life, which is option B. Let's proceed to question number 18. Here, they say in the diagram, O is the center of the circle. If the reflex angle ZOY, which is this angle here, is 300 degrees, find angle ZSY, which is this angle here. Of course, we know that if this angle here is X, this angle here, angular center, is twice angular circumference. So this is 2x, it's twice this. So meaning that 300 plus 2x equals 360, which is angle at a point. So 2s is equals to 360 minus 300. 2s equals 60. So x is actually 60 all over 2, and which is 30. And that is angle, of course, the angle we are looking for is angle ZSY, which is 30 degrees. And that is option D. We proceed to the next question, question number 19. Please, if you are still enjoying our tutorial, we appreciate you enduring up to this time. Go ahead and subscribe if you have not done so. And remember to share this video. Go to the comment section and tell us how you feel about this tutorial video. Now here, we want to express this as a single fraction. So we are going to, what we do here now is bring this and take the product of their denominators. So when you divide the whole of this by this part will be left. If you divide the whole of this by this part will be left. We'll multiply by 1. We have 4x minus 7. When you divide, that is 3s plus 5, 4s minus 7. If you divide it by 4x minus 7, the whole of this will cancel out. We are left with 3s plus 5. Multiply by 1, we have 3x plus 5. So this gives us 4s plus 3s is 7x. Minus 7 plus 5 is minus 2 all over 3x plus 5 into 4x minus 7. So now, if you open this bracket, you have 7x minus 2 all over. Now, use this 3s to multiply 4s. That's 12x squared. 3s times minus 7 is minus 21x. 5 times 4s is plus 20x. 5 times minus 7 is minus 35. This becomes 7x minus 2 all over. We have 12x squared. Minus 21 plus 20 is minus x, then minus 35, which is option A. And now we move on to the last question for today. Here we want to simplify these fractions, and we are going to use BODMAS. BODMAS is bracket of division, multiplication, addition, and subtraction. Now there is, you can see division here. So we are going to handle these two together. we are going to have 2 over 3 plus 3 over 4. Then change this to times and take the inverse of this. That's 8 over 7. Then minus 11 over 12. So we go on to 2 over 3. Then plus, if you look at this, 4 can go here. 1, 4 here is 2. 3 times 2. 3 times 2 will give us 6. So this is 6 all over 7 minus 11 all over 12. Now we can take the addition. We can take the addition, or of course, we can take even all of them. Together, the LCM is 84. If you look at 3, if you look at 3 in 84, what will that give to us? We have 2 here, and 24, we have 8. So that's 28 times 2, that's 56. 84 divided by 7 will give us 12. And then if we do 12 times 6, 72. 72 here. 12 times 6 is 72. 12 can go in 84. If you look at 12 can go in 84, 7 times this, you have 77 here. So now if you add 56 plus 72 minus 77, that gives us 51. So here we have 51 all over 84, which we can reduce using 3 to give us 17 all over 28. So this will be the answer. We look at, that is option B. Option B. So that is how we close up for today's tutorial. Thank you very much for your endurance up to this time. We've been able to treat question number 11 to question number 20 in this part 2 of our series. We are going to question 50. Be with us next time as we drop another video that will cover question number 21 to question number 30. If you find this tutorial quite impactful, why not go ahead, if you have not subscribed to our channel. Click on the notification bell so that when next we drop another video, you'll be among the first to receive it. Share this video so that the YouTube algorithm will take it to other students that might also need it. Go to the comment section, tell us how you feel about this video. Your feedback will help us to improve our services. This is Math Minders Academy. Goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the